I'm here today to talk and share a bit more about the sorts of things that we do here at GrabTaxi um, in the field of data science, and particularly how we use machine learning to sort of solve some of the business problems or challenges that we face and see. And today I'm going to talk about the age-old question, especially for those of you who live here. You know, taxi uncle, where are you? Right. So, for those of you who have spent some time here, for those of you who sort of traveled in here and have been getting around by taxi, this is a common sight, right? If you see cabs, they could be available, they could be hired, they could be on call, they could be going to a particular place, they could be trying to change shift, they could be busy but not have a passenger on board, right? There are so many different sort of states of the world that can exist in sort of the taxi driver's sort of day, right? And this is a challenge, right? Because we're not as a third-party app that's sort of aggregating all of the taxis, all of the cars, and in some of some of the geographies that we're in, bikes as well. We can't. We're not linked in to the systems that are on board these taxis, right? So while a consumer on the street, while a potential passenger who's going to do a street hail can sort of see, roughly speaking, what is the current status of the taxi, we don't actually know, right? And if you think about sort of what we're trying to do here in terms of matching drivers and passengers, we sort of operated, because we started out in sort of the taxi space, taking the street hail to something that could scale, right? So instead of you're on the street, you're sticking your arm out, whichever taxi driver happens to see it, sort of responds to it. What we started out trying to do was to say, well, all right, well, we know where you are, we know where sort of the drivers in that area are. Can we sort of do a hail at scale, right? So say broadcast your intended trip to the end drivers within a certain distance of you, and then whoever is first to respond gets it, right? Challenge is that that is putting the taxi driver in a tough spot, right? They're trying to make they're first of all they're trying to drive, and they're trying to think about, should I respond to a street hail? Maybe it's time to change shift. Do I want to grab lunch? Do I need to go to the toilet? And unfortunately, at some point in time, although increasingly that's not the case, perhaps respond to a competitor app. And then in the midst of doing all of these things, they're also trying to process the information that we're sending to them in the app, right? Where the pickup point is, where the drop-off point is, if there are any discounts that apply, is the passenger paying cash or credit? And they're trying to process all of this information while they're trying to keep the car on the road, right? And what is the driver's response to this, right? Increasingly it is to, at some point was to bid first, right? Because the fastest fingers win, and then sort of figure it out after that, right? So they hear the ping that a taxi that a passenger wants to be picked up. They sort of press without necessarily sort of processing that information fully. Now the drivers who don't win feel bummed out, right? Like if we broadcast to 40 drivers around you, only one can win, 39 lose, right? So because they feel rejected, sort of the low win rate and encourages them paradoxically to bid more, right? It's sort of like the lottery effect. And then the winning driver, having not necessarily sort of fully contemplated, do they want that trip, might then end up canceling the ride when they have the time to finally look at it, right? So that causes passenger unhappiness. So the way that we approached it, and there are various ways to think about this, but the way that we thought about it was ML problem, right? Which is that if we could build a predictive model of the probability that any given driver would bid or respond to any particular job, and if we combine that with real-time information such as distance, bearing speed, so on and so forth, we could direct jobs basically to a much smaller pool of drivers who are most likely to be available without having to sort of do any hard behavioral change, such as them trying to indicate their status, right? Which, although the option to do so in the app has existed for a while, it's sort of very hard to drive to change very entrenched behavior. So, sort of we looked at a whole bunch of features, everything from notions about the driver, are they are they single shift, split shift, what fleet are they a part of, information about the vehicle, both in terms of real-time stuff, where they are, where they're going, where they've been, their vehicle type and age, the performance of the driver on our system, information about the bookings, payment method, weather, sort of the list goes on and on, right? And we sort of looked at a set of about 50 features that we narrowed down to 10 via dimensionality reduction, and then finally, sort of for ease of implementation, given that it has to run at massive scale, right? You're gonna call this for every driver booking pair, like in real time, right? So the engineering performance in production was extremely critical for us to get right as well. And then finally, we narrowed it down to 5 using exhaustive search. And I should note that aside from sort of human-crafted features, we also sort of apply deep learning to see if just doing it on the raw data set would in fact beat sort of human feature engineering. So we tried a bunch of different techniques, really assessing them against A, sort of the accuracy of their results, B, how long it took to train the model, and then C, really what was the performance of it like in production, given sort of the real-time constraints, right? And it was sort of clear that sort of initial exploration with linear types of methods clearly did not work, right? Like getting inside the mind of a driver, sort of the thinking process of a driver is highly non-linear as it turns out. And for those of you who don't know what conditional inference trees are, this is what it looks like. But basically, it's sort of captured. If you look at the performance, performed among the best 2 or 3 techniques, and had the benefit of very fast training time, and more importantly, very fast sort of practical performance when it runs in prod. So the results of this was that by being able to establish sort of a probability bound for is a driver going to respond to that particular job, it sort of allows us to construct guarantees around how many drivers do I have to broadcast to make sure that I have a certain probability that my job is going to be fulfilled, right? And that allows us to then broadcast those jobs to a smaller set of drivers, right? You minimize sort of spam, right? Which as you scale on both sides of the market, as we have, can sort of become a challenging thing. So we're getting the messages and the jobs to the drivers who want it the most, or who are available to take it. They have more time to respond, right? Because they're not in this rush to sort of press it fast, because they're not fighting with the n-1 other drivers who are in the vicinity. And because they can take more time and it's really targeted to what their preferences are, that allows us to significantly lower what the cancellation rate is, right? So, they're more likely to get the job, and they're more likely to get jobs that they want, right? And they're, more importantly, far less likely to get jobs that they don't want, right? And so that leaves the driver in a happier place, and it leaves the passenger sort of the beneficiary of a lower cancellation rate, right? So, this is just sort of one of the several things that we're doing on the machine learning and broader data science side at Grab. Everything from figuring out what is the optimal way to price, what is the way to best match drivers and passengers, estimate time of arrival, all of these things. We strongly believe that machine learning on the sort of unique data set that we have is what's going to drive a lot of the competitive advantage in this business. I should plug at this point that we are recruiting. So, happy to have a chat with any budding machine learning or data scientists, guys in the audience. And with that, thank you very much.